Okay, in this video, I'm going to show you how you use the first and second laws of uniformly accelerated motion. And uniformly accelerated simply means that acceleration is constant, such is the case of gravity. So if we know what the initial velocity at takeoff is, as well as flight time, we can figure out the velocity, the vertical velocity of a projectile at any given time during flight. And this equation is nothing new. This is really the relationship between acceleration and velocity, and we know that acceleration, oops, that's supposed to be v, is the change in velocity, final velocity minus initial velocity over time. And if I simply solve for final velocity, I get this nice little equation here. And we also know that acceleration is constant, so let's say g equals negative 9.81 meters per second squared. That gives us the velocity of a projectile at any given point during flight. And I'll show you how you can simply use that in order to figure out that for a particular projectile. The second law gives us an equation to calculate the final position, final vertical position of a projectile if we know the initial velocity and as well as flight time. And if you see this right here, this is the final vertical position equals the initial vertical position plus initial velocity and time plus the acceleration of gravity times t squared over 2. This actually simplifies to this delta y, which is the vertical displacement, equals the initial velocity and time plus 1/2 acceleration of gravity t squared. I'm going to come back to this in a sec because this becomes very important when you're trying to figure out jump heights, for example. You know, we do this all the time when we're trying to figure out the height of a high jumper or a pole vaulter. In a few weeks, we're going to look at counter movement jumps. So there is a direct relationship between flight time, for example, and jump height because we know that gravity is constant, because we know that gravity is 9.81 9.81 meters per second squared. Again, ignoring air resistance here. If we look at a projectile, it's this nice parabolic shape, and the velocity is going to have a certain takeoff magnitude in both the vertical direction as well as the horizontal direction. But at the very top here, its velocity of any projectile is going to be 0, as you probably guys already know. And so it goes up to the top and then eventually has to come back down. This vertical displacement is otherwise known as jump height, right? So you look at a high jumper, you look at a pole vaulter, like counter movement jump, as I mentioned earlier, you can figure out what that jump height is. Now, another use of these projectile equations is to figure out how far something or someone jumps, what is called horizontal displacement or range. So this would essentially be in the x direction. This is actually fairly straightforward to find because we know that in the horizontal direction, velocity is constant, right? Because gravity only works in the vertical direction. So this equation is simply the relationship between velocity and displacement, right? V equals displacement over time, or if we really want to be technical, V in the x direction is the change in x over time, and then you simply solve for displacement, which is delta x, and by multiplying both sides by time, you get this nice little equation. So if velocity, for example, was 3 meters per second and time was 1 second, then the horizontal displacement will simply be 3 meters, right? Because we know that horizontal velocity is constant in that direction. So let's take a look at an example here. I'm going to show you, I'm going to switch screens real quick. Just bear with me. This is actually from your course key. And I'm going to take a look at, let's see, I think this is the first one here. Yeah, so in this example, a football is punted in the air with an initial vertical velocity of 15 meters per second and an horizontal velocity of 15 meters per second when it leaves the kicker's foot. What is the vertical velocity 2 seconds after it leaves the kicker's foot? So I'm actually going to go over this problem and solve it for you. You can go ahead, you can pause this video, and if you want to solve it on yourself, but it's pretty straightforward. So I'm going to switch back here. And those of you following along know that if the horizontal velocity is 15 meters per second and the vertical velocity is 15 meters per second, what is the takeoff angle if they're both equal? And if you guess 45 degrees, then you are exactly correct, right? That is 45 degrees. Cool. So its horizontal velocity, as the problem said, was 15 meters per second. Its vertical velocity was also 15 meters per second. We know that the path or trajectory of a projectile, in this case the football, is going to make this parabolic shape like this, correct? At the top, what did I say earlier? V, and I'm just going to put here y for vertical, okay, is equal to 0. This is at the apex. Okay. Now the question asks, what is the vertical velocity 2 seconds after it leaves the foot, basically the football? So I'm going to say final velocity equals initial velocity plus gravity times time. Well, what is the initial velocity? Well, that's given, 15 meters per second. We know what gravity is, negative 9.81 meters per second squared times 2 seconds. I apologize, running out of room there. So you can see here, you do the math. You can figure it out from there. Always check your units. 15 meters per second, negative 9.8 meters per second squared times 2 seconds here. You're going to get a negative number, correct? Makes sense too, because as the football is going up, eventually it's going to hit 0, and then eventually it has to come back down. This is how it looks. So therefore, you get a negative velocity when you figure out the math from there. And it should be obviously in meters per second. Here's another question for you. I think you guys already know this. What is the horizontal velocity of the football 2 seconds after it leaves the foot? Correct. 15 meters per second. Remember, it's constant. Okay, good. Now we're going to use the same scenario and figure out, well, how high. If you follow football, we're always interested in flight time, or hang time is what they call it, as well as horizontal displacement. But what if we want to know how high it went, right? Like if we're looking at other projectiles in a high jump or pole vault. I just showed you earlier that jump height or projectile height really is just vertical displacement here. This right here, this is, I'm going to go ahead and draw this. This is height. Let's call it jump height. Actually, no, since we're using a football, just call it projectile height. I'm not going to really do any math, but I'm actually going to derive a little formula for you. I showed you earlier, according to the second law of uniformly accelerated motion, that the vertical displacement is equal to the initial velocity, vertical velocity, times time, plus 1/2 gt squared. Well, what did I say the vertical velocity is at the very top here? 0. So if we take that into account, we simply want to know how high, or what is the change in vertical position from the ground to its highest point. So I can figure out the time it takes to go up or the time it takes to go down. Time it takes to go up is going to be flight time over 2. Time it takes to come down is also going to be flight time over 2, right? Half the time. So this change in y equals, because the initial velocity is 0, equals 1/2 the acceleration of gravity times half the flight time squared. And if you work out the math, because we know that gravity is 9.81 meters per second squared, do the math. I want you guys to do this, but you should get t squared. That is the governing formula between flight time and height. In fact, in a few weeks, I believe it's module 8 or 9, we're going to be doing jumping analysis and more specifically looking at squat jumps and counter movement jump. We're going to be using an app to give us that. And the app essentially uses flight time in order to predict or estimate height, and it uses this nice little formula. So when you're doing this in eventually when you do this in module 8, you have to write up a report. You have to write up how the app actually calculates jump height based on flight time. And so, and we'll go over that again once we do the actual module. Okay. So let me switch real quick back to Korsky because I think it's important. And we can work out this problem together. Let me go ahead and share. I think it's this one. Here, voila. So here we have, if a trampolinist is in the air for 1 second, how high does he or she jump? Right? It looks like a pretty simple problem here. However, remember what I said earlier. Half the time it takes to go up is equal to half the time it takes to go down. So I'm going to use that same exact formula I just showed you. It's actually pretty simple, right? You don't have to even do math. If the vertical displacement is equal to 1.22625 t squared, what do you think the jump height is for this trampolinist? Good. Now you know what to do, or now you know what to put in this Korsky.